Okay, so finally I am going to discuss the part A questions. So honestly speaking, I am not able to solve all the questions. I only able to solve 17 to 18 questions. So I will discuss all that in detail. Okay, so let's see about what is the first problem. Okay, yeah. So this is the first problem. They are telling consider the triangle subtended on the surface of a sphere of radius 1 by joining this and this points with arcs of great circles. The area subtended by the triangle on the surface of the sphere. Okay, so the language is bit confusing. So pause the video and read it by yourself. Then try to think. And they also give a hint that drawing a figure might help. Okay, so try their hint, then look at the solution. Okay, so just a minute, I look at the points. Yeah, 001. So look, they are mentioning 3 points. This 001, this is the x-axis, this is the z-axis, this is the y-axis. Okay, now this is x-axis, so it is half. Let's say it is half, and you are moving along y-axis and move another distance root 3 by 2. So this point is half root 3 by 2, and it is on the xy plane, so z coordinate is 0. Similarly, if you move minus half in negative x-axis and root 3 by 2 in y-axis, so this point will be minus half root 3 by 2 0. Now remember, these 3 points are on the on the surface of the circle. Okay, surface of the sphere. So if you join like them, so it is like a arc. Okay, and this is also like a arc. So if you, so this is, now you can visualize the figure. Okay, so if you have a circle, then what 3 points they are telling about? They are telling about there is some point here and there is some point here. Okay, and you are joining this. Okay, so this is the surface this triangle is making. Okay, now look at the figure, this figure. This is the bigger figure. So here theta, what is theta limit? Theta goes to 0 to pi by 2. Okay, theta is 0 to pi by 2 because it is in the upper half plane for sure. Now what is the limit of phi? Okay, that is important. So this point, for this point, what is phi? This is phi 1, let's say. So phi 1, you can easily find that tan phi 1 is root 3 by 2 divided by 1. Okay, so this phi 1 is 60 degree. So it starts from 60 degree, that is pi by 3, and it moves to minus 1 by 2 root 3 by 2, this point. Okay, this is the point. Okay, so what is this total angle? This total angle, you can similarly find that this angle is pi by 3. So pi minus pi by 3 is 2 pi by 3. So phi moves from pi by 3 to 2 pi by 3. Okay, so now you can do the surface integral, that is r squared sine theta d theta d phi. Okay, so r square, and r square is simply this is constant. Okay, so it is 1 square. Sin theta d theta will give you 1, and 2 pi d phi will give you 2 pi by 3 minus pi by 3, that is pi by 3. So the main thing, you have to visualize the diagram. Okay, so this is the diagram. So here is a point, here is another point. They are on the surface of a, they are on the surface of the sphere, and you are joining this. Okay, like this. So you have to visualize this diagram. That's why they are telling that this take this hint. Okay, so this is the option. Now look at this problem. So they are telling basically pause the video and read it by yourself first. Okay, so this point is blank, there is no charge. Okay, and these 4 points have 4 charges. Okay, now the magnitude of charge, there are no charge at the position of white circle. There is no charge as position of the white circle. The black solid circle on its vertices represent point charge with charge minus q. So all these charges are minus q. Okay, now if you know the pentagram diagram, so this is a pentagon. Okay, so there is some center O. Okay, so these are all similar triangles. Okay, so if this length is a, suppose this length is also a, 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 f, and this length is obviously also a. So all these are same. Okay, so if you draw a perpendicular from this, so this length will be a by 2. Okay, so sorry, and you have this components. Okay, so this will, this plus minus q charge will acting a force on upper side direction, say plus q charge is here. Okay, so it will push and it will also uh, pull these sides. So your net component, so this is theta, and this two will be 60 degrees. So contribution of cos theta is half, and you have two components of this. Okay, so you have, here is a force say F, and you have minus 2F cos theta, that is cos theta is half. So F minus F is 0. So from these two contributions, they are all 0. Okay, so now only this contribution will left. So this minus q will pull it in this direction. Okay, so there is minus q, and they already mentioned that this position is r vector. This is r vector, so this is also r vector. Okay, so this is minus q r by 4 pi epsilon naught r q. So you have to basically think that this charge, and this charge doesn't giving any contribution. They are cancelling the net contribution. Okay, so this is the second question. Now this is the third question. It is uh, they are telling that in two-dimensional surface, what is the value of Ca at very low temperature? Okay, so for this is a very general law that Cv proportional to T cube for 3D solids and Cv proportional to T square for 2D solids. Okay, if you remember this, you can directly take this. Otherwise, you have to derive. So for derivation, your g omega d omega, that is density of states, it is proportional to h cut omega d omega, it is proportional to, okay, e to the power h cut omega by kt minus 1. Okay, so if you now calculate the average energy, so there will be an omega square. We have to integrate this. Now you put h cut omega by kt x is equal to x, suppose. Okay, so your e is proportional to t cube for 2D solids. Okay, so cv proportional to t square. And now this is a statement based question. I didn't solve this. Okay, now this is the fifth question. So they are telling that it is leaving water surface, water is leaking from this small hole. This hole has a surface area of a, and this upper area is a prime. Okay, probably, yes, what is the area a prime of the stream transverse to the fluid velocity? Okay, so this is not a prime. They are asking that what is this area a prime when it moves down a height h. Okay, so from the Bernoulli's theorem, you know that the water coming out from this surface A, has velocity root under 2g into the height of this vessel, that is root under 2g. Okay, you know equation of continuity. Okay, so this surface area is a, so a into v is equal to this surface area is a prime into v prime. Let's say, now what is v prime? To calculate v prime, now water is coming to this surface, so what is the total height? What is the total height water is going? Total height is h plus h. Okay, so v prime is directly equal to 2g into h plus capital H plus small h. Okay, so your A prime is simply A root under H by H plus H. Okay. Now this problem I have a bit confusion because I didn't solve exactly. I can't match the exact answer, but I can tell you the approach, that what should be the approach. See, the theory is, basic theory is, when this thing, first read the question, pause the video and read the question. Okay, so the theory is, when this loop is going inside this region of magnetic field, so the flux is constantly changing. Okay, because this area is changing, so the flux will constantly change as the loop is completely entered to this and moving in this way. Then no flux is changing, so its velocity will remain same. Then finally, when this loop trying to exit from this region, then again flux will change because of this electric field will induced, EMF will induce, and because of that velocity will also change. Okay, so how this works, let me tell you. So suppose at a particular moment the velocity is v, okay, and it is moved a distance x, okay. So what is the EMF induced? EMF is equal to d phi dt, okay. Now what is phi? What is this region area? So see, this length is always a, the length of the square, and it's moved a distance x. So what is this area? B into a into x by dt. So B A dx dt actually, okay, B A dx dt, that is B A V. So what is the current in this loop? Is I is E by R is equal to B A V by R. Now you know the law, that is the if current is flowing in a magnetic field in some direction, then force is equal to I dot dl cross B. Okay, so I dl cross B basically. Sorry, I dot, not dot, I dl cross B. Okay, so this is the force law. Okay, so I know that don't recognize the exact name, but this is the force acting on the loop. Okay, so force is I B I L. So here L is basically A. So B square A square V by R is the force. So what is your acceleration? Acceleration is B square A square V by M R. Okay, so after it, when this x becomes a, when uh, this loop completely enters into this region, then flux will stop changing. Then velocity will be fixed. Okay, so v dv dx, acceleration is equal to v dv dx is equal to b square a square v by r, v by mr. Okay, so if you now v cancel, so if you integrate both sides, and obviously the force is pulling this side. Okay, so if you calculate the direction, it will oppose the motion by Lenge's law also. So there is also a minus sign always. Okay, so suppose the velocity will be v1 when it completely enters this region. So v1 minus v naught initial velocity is equal to minus b square a square a mod. Now what is the distance x it's traveled? Is traveled the distance a. So a square into a simply will give you a cube. Okay. So v1 is equal to v naught into 1 minus b square a cube by a mod v naught. This is the first part. Okay. First part. So after entering this region, this will be the velocity. Okay. Now, when it crosses this region, the same kind of thing will again happen, and again the velocity will decrease by same amount according to me, but according no, not to them. So I think the answer should be like this one minus two b squared a cube by a mod v naught, but they are giving a square. I don't know why this, how this square is coming. So this is my approach. If you some of you have solved it in example, then please let me know by comment. Okay, now this is a logic gate question, and it is a easy question. I mean, you can do it. So a b c you have given, and what is y? So y is basically, if you look at the diagram, so this gate, what is the input of these gates? This gates had an input A, C. Okay, the output of this gate. So A and C are giving as input, and the output of this gate is AC. What is the output of this gate? This gate is AB, and for this gate, output is simply BC. Right. So your Y is AB plus BC plus AC. So you can now write simply the 0 0 0 0 1 1 1 1. Simply write B in this way: 0 1 0 0 1 1 0 0 1 1, and also write C, and then calculate this AB plus BC plus AC. So I am calculating the first one, suppose. So the first one is all are 0. So AB is equal to 0, BC is also 0, 0 into 0 is 0, AC is 0 into 0 is 0. So 0 plus 0 plus 0 is equal to 0. The first one will be 0. Now you can calculate similarly the other ones. So you can finally see that the first option is matching. Okay. This problem I have a bit confusions here also because I didn't get the H cut. Okay. How they are getting this H cut, I don't know. Okay. So I am leaving this now. This is a diagrammatic question. I will explain this in, I mean, not very detail, but you can uh, refer to the book Resnick Relativity. This Resnick Relativity book is extremely good for this topic. Okay, they have geometric representation of relativity. There is a chapter, and they explain these things very good. Okay, so if you know the space-time diagrams actually, okay, so this is future light cone. Okay, this is future light cone, and this is past light cone. Okay, and these are space-like regions. Okay, so if you try to draw a line like this, okay, this line is definitely not possible for because this line has a slope which is implies that velocity is greater than c. So these two regions are causally disconnected. Okay, there cannot be any communication between these two lines. Okay, but suppose you are having, this is future past light cone, future light cone, you are having these two region, these two events, they can causally connected. Okay, so let me draw it clearly. So suppose you have this, so these two events can connect. Okay, similarly similarly, so suppose there is this region and this region, these two also can connect. Okay, but this and this cannot connect. Okay, because they cannot communicate because their velocity should be greater than c. No signal can pass. No signal can travel greater than the speed of c. Okay, so the first option will be the correct option. Okay, now this is also a good problem from torque concept. Okay, so now don't equate the force for this region because you don't know what is the hinge force in this. So you have to calculate the net torque should be zero about this point. So the torque, there is two kind of torque here. The torque due to self weight, and what is the distance of this mg from this region, that is L by 2 into cos theta. Okay, so this mg is acting at a distance L by 2 cos theta. This distance is L by 2 cos theta. Okay, now what is this? This spring will tilt us slightly, but you can assume that it is the height of this, the extension of this is almost L by 2 sin theta. Okay, so k into x, the force is k into x, and what is this what is the direction? This is the direction, and what is the distance? The distance is L. So kx is acting, and the distance of the force from this hinge point is L. This distance is L. So kx into L, and what is x? X is simply L into sine theta. This height is L into sine theta. I am approximating that this height is almost same as this because this is very small triangle, small base triangle. Okay, so it is approximately L sine theta. Okay, so if you equate this to the net torque is zero, this equation, you will get this tan inverse mg by 2kl. Okay, now this problem I have a bit confusion. I didn't understand their language very clearly also. Okay, so suppose this is the window. Now at 9 p.m. sun is directly perpendicular to it. Okay, so it, the rays falling it is directly perpendicular. Okay, directly perpendicular. Suppose this is the sun. Okay, now if this is the base, now the sun rays we covered this distance, maximum of this distance. Okay, now if this is 90 degree and this is 1 meter. Okay, so now this is should be also, I mean, they are not mentioning the language clearly, but I think this should be 1 plus 1 root 2, but I am not sure about it. I mean, I have confusion about the language actually, that where the position of the window, suppose this is your wall, So the window is like this, or this is your wall, your window is like this. I have a bit confusion about this, so leave it now. Okay, now this problem is also straightforward. So what is your average xt and what is your average pt, they are asking. So don't bother about that what is the t. The xt is also some combination of a and a Dieger, some combination of a and a Dieger, and p also some combination of a and a Dieger. Okay, so if you take the average between any states of a and a Dieger with same, then it will always be zero. Okay, now let me tell you the what is the exact form of xt. That is x cos omega t plus p by m omega sin omega t. Okay, and pt will be p cos omega t minus m omega x sin omega t. Okay, so this is the exact form, and your x is simply a plus combination of a and a Dieger, and p is also combination of a and a Dieger. Okay, so it is root under h cut by 2 m omega a plus a Dieger, and p is similarly that kind of a thing. So it is combination of a and a Dieger, both this xt and pt. Okay, so the answer should be zero no matter what is the combination. Okay, now this problem is saying that two ideal gases have same atomic mass with atomic mass m and mb such that ma and mb, two gases the same number of moles kept at same temperature confined in container with same volume. So which gas will exert more pressure and which is higher RMS velocity? So pressure is simply is number density into kT. Okay, and number density is nothing but proportional to n, number of moles. Okay, and they are having same volume, so pv is equal to nRT. N is the number of moles, say no number of mole. Okay, so if volume is same, number of mole is same, so it doesn't matter what is the mass, they will exact same pressure. Okay, and the rms velocity is 3 kt by m. Okay, so so are they are telling about RMS momentum. So if this is RMS velocity of the mass A, so if you calculate RMS momentum PA, that is MA into VA. Suppose this is VA. So your result will be 3 kT into MA. So if MA is more, then gas A will have more RMS momentum. Okay. Now this is a problem about accuracy and time of data collection. So the formula for this is sigma square proportional to 1 by t. Okay, so here accuracy is decreasing 5%. So time should increase 25. Okay, 5 time should increase 5 square is equal to 25 times. Okay, so initial time is 10 minutes. So final time should be 200, 250 minutes. So additional, they are telling about additional time, asking additional time. So answer should be 240. Okay. Now this problem I will give a detailed explanation. So if you read the book Vigo's Optics of Light, so here there is a concept of wedge shaped film. Okay, so suppose there is a wedge shaped film of angle alpha. Okay, now if a ray is falling here and some part of is reflected and some part of is transmitted. Okay, so it will some part of is transmitted. Okay, and some part then again reflected, some part again transmitted, this kind of thing. Okay, so there is two kind of interference due to reflected film and interference due to transmitted film. Okay, so the interference due to reflected ray interference due to reflected ray, the condition for this is 2nd cos r minus alpha. This is the alpha is the angle of the wedge and r is the diffraction angle. So this is suppose I, then this is r. Okay, so and n is the diffractive index of the material is 2m plus 1 lambda by 2. So for the reflected ray case, this condition should be the constructive interference condition, because one is reflected at a denser medium and one is reflected at a rarer medium. Okay, so this is the case. So this is the reflected ray case. Okay, And for the transmitted ray, for the transmitted ray interference, the condition will be 2 in d cos r minus 2 alpha is m lambda. Okay, so the condition, constructive interference condition, this is, so condition remains as it is because both the rays are passing through tensor to radar medium. Okay, so that's why condition remains same. So in this problem, if you see that they are incident normally and there is a flat film, no alpha is given, so simply your condition will be 2 nd is m lambda. Okay, so if you solve this, you will get d as, sorry, in you we are given d and lambda probably. Yeah, thickness of the film d is given and lambda is given, so you can find what is n. Okay, now this problem I don't know how what is would be the approach. If you don't know what is a tan hyperbolic series, then I don't know what is the approach. Okay, so I didn't can't do it. Okay, this is also a, I mean, you can solve it if you know the theory. So if you have a matrix and suppose this is, I am giving you an example. So suppose 2 4 6 and 3 uh, 6 and 9. Okay, so you can write this matrix as, take 2 into 3 common, you will have 1 2 3 1 2 3 1 2 3. Okay, so for this kind of matrix where all the row and column resembles each other, so the eigenvalues of this matrix, this is a 3 cross 3 matrix, so eigenvalues will be, one eigenvalue will be similar simply trace. Okay, so the trace is 14 here. Okay, and other two eigenvalues will be 0. So for this kind of matrix, any matrix, one eigenvalue will be trace and other all eigenvalues will be 0. So suppose this is an n cross n matrix and one eigenvalue is trace, there is one eigenvalue that is trace. All other n minus 1 eigenvalues that is 0. So it has n minus 1 degenerate eigenvalues and one other non-degenerate eigenvalue. Okay. Now this problem is also, they are giving too much language, okay, to confuse you, but it is simple. Okay, so in this frame they mentioned that what is the tau. Okay, that is simply h by c. So they are asking that what should be your t in this frame. So t is lambda tau, sorry, gamma tau. Gamma, what is gamma? Gamma is simply tau into 1 minus v square by c square. Okay, so this is the right option. Now this is another problem. So they are asking you what is v out, basically asking what factor should you multiplied, okay, in v out. So what is this a? So if you draw the, I mean, if you think that current is flowing through this region, so what is current? Current is simply v in divided by z. Z is the impedance of this device. So z is simply, now this is a rc circuit. Okay, so z is r plus xc. So what is xc? Xc is minus j by omega c. Here j is the complex j square is minus 1. Okay. So r minus j by omega c. So this is the this is z value. Now what is v out? V out is simply I into r. Okay. So v in by z into r. So you can now write v out is equal to v in. Now put the value of z here. So you will get 1 minus j divided by omega rc. Okay, so and omega is 2 pi f. So this is a complex number. So if you take the, I mean, mod of this complex number, you will get the option 1. Okay, so option 1 will be 1 plus 1 by 2 pi f r c whole square root under. Okay, so this is the option 1. This problem I don't know this concept. Okay, so I am skipping that. Now this problem, you have probably read the problems of reflections and transmissions of electromagnetic waves. So probably you may solve it because these things you have done in your semesters. Okay, semester exams. Okay, so this is the boundary. Now look at the direction of E. So this is the angle I. Okay, this is the angle I and E is perpendicular to this direction. Okay, so this angle is 90 degree. So what is this angle? This angle is 90 minus I. This angle with this line, this angle I am telling 90 minus I. So what is the perpendicular component? Perpendicular component is E cos 90 minus I, that is E sin I, right? So similarly for this E prime also, the perpendicular component is E prime sin I, and for this E double prime, sorry, and for this E prime also similarly, that is E prime sin R, the perpendicular component is E prime sin R. Okay. Now you know the concept of continuity of D perpendicular. D perpendicular is continuous through any medium. This is the standard boundary condition. Okay. So in this region they given that it is epsilon, and in this region they given it is epsilon prime. So simply multiply epsilon into the perpendicular component, that is E sin I plus E double prime sin I is equal to E prime into the perpendicular component of electric field in this medium, that is your E prime sin R. So the option will be correct option. Okay. This is a problem like a magnetic cage. Okay, so you know this from class 11 that when there is lighting outside, you should keep yourself inside a car or inside a iron box, so that it will act like an electric cage. So if you you kept yourself inside a conductor, so if you kept yourself inside a conductor, then electric field cannot pierce it. Okay, so there is zero electric field inside a conductor. Okay, so if you are safe when you are safe inside an iron car when there is lighting outside, so it acts as a Faraday cage. It is known, or electric cage. So they are telling about the magnetic field. So the same thing. The what is conductor? The conductor has epsilon, that is permittivity tends to infinity. Okay, so if your epsilon tends to infinity, this is a conductor thing. So the same thing they are asking, that you have to minimize the earth's magnetic field. So this can be achieved by, so keeping the setup in a place completely covered with a sheet of metal of very high magnetic permeability. So the same thing like this, if your epsilon, the electric permittivity is very high, then the electric field inside it is almost zero. So that's why you are safe when there is lighting outside. So the same thing is there. If your magnetic permeability is very high inside a medium, then magnetic field cannot pierce it. There is a zero magnetic field inside that. Okay, so this is the right option. There is a magnetic cage like thing. Okay, this language I am also not very sure. Okay, now this is also a, I mean, it is okay, but it's a bit calculative problem. You may do calculation mistake in this problem. Okay, so what is B simply? B is mu naught I by 2 pi R. So forget about this blah blah. It is simply I by R. Now what is I? I is Q by the time period, that is 2 pi by omega into R. Omega is V by R. Okay, so Q by 2 pi, I should write proportional. Okay, so I is Q by T, 2 pi by omega. Omega is V by R. So there is R square. So they are telling in both the cases V are same. So if you have to keep V same, now you know that mv square by r, the centrifugal force, is the electrostatic forces acting by the charge. So the center charge, let's say q, and the outside charge they are mentioning minus q and minus 2q. So q by 4 pi epsilon naught r square, whatever. So your R, now V is fixed for both the case, this Q is fixed. So your R simply proportional to what is the charge you are putting here. Okay. So what is the charge is revolving, this is directly proportional to R. So R is directly proportional to Q. So the first case, R1 is proportional to minus Q. I mean, don't take the sign seriously. R2 is proportional to, because this is an attractive force at all. So that's why it's revolving like the gravitation. And R2 is 2Q. R2 is proportional to 2Q. Oh, so this is the two case, that is R1 and R2. And charge is itself charge. So the B1 is proportional to Q by Q square. And B2 is proportional to 2q by 2q a whole square. Okay, so what is b2 by b1? They are asking b2 by b1, so it is simply 1 by 2. Okay, so don't forget that they are asking that v is fixed. Your v is, if your v is fixed, then omega and r are not fixed. Okay, omega and r will change. So that's why some of you may mistake with option two, but this is not the true. It is the true option. Okay, yeah. So and 25 is also very complicated. I don't know actually, honestly. So yeah, these are the problems I have solved in part A, and yeah, that's it for today. Thank you.